Okay, let's unpack this. Welcome to our deep dive. We're looking at these sources you shared about making sense of numbers visually.
Yeah, the material jumps right in, doesn't it? Suggesting that seeing data, graphically sticks in the mind better than just reading about it.
Exactly. So our mission today is basically to quickly pull out the main ideas for three common types:
Hmm.
the bar graph, the pie graph, and the histogram.
Right, how these tools turn sort of raw numbers into pictures that actually make sense quickly.
Uh-huh. It's fascinating how visual shortcuts work for understanding complex stuff.
Absolutely. They're designed to make it all accessible, memorable, at a glance.
So the material kicks off with probably the most common one, the bar graph. What does your source say about that?
It calls it the simplest, most widely used graph. Basically uses rectangular bars for numerical data.
Simple enough.
Yeah, and the key idea is the bars are equally wide, but the height, that's what shows the actual value.
Right, like in example one they gave, seeing speeds of, say, a bike versus a train. The heights are totally different.
Exactly, and you typically put the categories, like the object names, along the bottom, the x-axis.
And the values, the speed or whatever, up the side, the y-axis.
Correct. And the source makes a specific point about leaving consistent spaces between those bars.
Why do you think they emphasize the spaces? Seems simple.
Well, I think it visually separates them, right? It underlines that you're comparing distinct, separate things. These aren't like continuous categories.
Ah, I see. So the gaps reinforce that discrete comparison. Makes sense.
Exactly. Keeps things clear.
Okay, so moving from comparing separate items to looking at parts of a whole, the sources bring up the pie chart next.
Right. The pie chart or pie graph. It uses sectors of a circle.
Like slicing up a pie, literally. Each slice represents a proportion of the total data set.
That's it. And the size of each slice, each sector, is determined by its angle at the center of the circle, the central angle.
So how do you figure out those angles?
Well, the source explains you take your total data value that equals the full 360 degrees of the circle. Then you divide up those 360 degrees proportionally for each data point.
Okay.
Example 2 actually shows this well. It uses those same speeds from the bar graph example and turns them into angles like 15 degrees, 60 degrees, 90 degrees, and so on.
Ah, okay. So you draw your circle, then you draw in sectors using those calculated angles. The angle visually shows the proportion.
Precisely. It's great for seeing composition, like what percentage each part makes up.
Though I suppose if you have too many slices, it could get messy.
Definitely. It works best with fewer categories.
All right, finally, the material tackles something a bit different, representing grouped frequency distributions. This is where the histogram comes in. How's this one distinct from a bar graph?
Yeah, this is a really important distinction the sources make. A histogram also uses bars, but it's specifically for data that's been grouped into ranges or class intervals.
Okay, ranges.
So the base of the bar along the x-axis represents one of those ranges, like ages 0 to 10, 10 to 20, like in example 3.
And the height.
The height shows the frequency, so how many data points fall into that specific range.
Gotcha. And unlike the bar graph with its spaces.
Right. The bars in a histogram are typically drawn right next to each other, no gaps.
Why no gaps here?
Because the base represents a continuous interval or range. The bars touching visually reinforces that continuity, that the data flows from one bracket to the next.
That makes perfect sense visually. The form matches the data type. And, oh, the source mentioned something about a zigzag line. Example 4.
Uh-huh. That's if your class intervals don't start at 0. You use that little break mark, the zigzag, on the axis to show you've skipped some space.
Right, so you're not distorting the scale, but you're also not wasting space showing a big empty area from 0.
Exactly. It's an accuracy thing. Shows histograms are really designed for that interval data.
So wrapping this up, what's the big takeaway? These tools, they're like powerful shortcuts, aren't they?
Absolutely. They turn potentially confusing lists of numbers into, well, intuitive pictures. Makes complex info graspable almost instantly, just like the sources said about that lasting effect.
Yeah, whether it's simple comparisons with bars, or parts of a whole with a pie, or seeing the distribution with a histogram.
Choosing the right tool is key. It really helps cut through the noise, helps you see the patterns in the data.
Okay, that wraps up our deep dive into graphical representation based on your materials. Hopefully this quick tour gives you a clearer picture of how these visuals work.
And why those little details, like spaces or no spaces, actually matter depending on the data.
Right. So as you think about all this, here's something to maybe mull over. How might showing the same basic numbers but using different charts, say, A bar graph of individual values versus a histogram grouping those values, how might that subtly change what someone notices or concludes from the data?
Interesting question. Definitely something to consider.